So happy Tuesday, everyone. Is everybody's okay? The attendance register is here. I know there aren't that many people here, but if everybody could sign it, that would be very helpful. So welcome to the seminar on reading research papers, scientific research papers. Is anybody here trying to read scientific research papers as part of their studies? 1, 2, 3, 4, 5, 6. Is there another person? Yes. Okay. Is anybody feeling a little bit, I don't know, anxious about the volume of previously published literature? Yeah, like the massive number. Does anybody get a little bit anxious about the level of complexity that's presented in the previous research papers? Have you ever wished that there was a strategy to reading previous research papers? Has anybody ever thought of if a strategy could exist on this topic? Yeah? Has anybody does anyone already have a strategy? Not this, I mean before coming today. Has anybody already developed a strategy for reading research papers? Did any of your supervisors say, here's the way you read a research paper? Here's the essential information you need. Yeah, so you got some training already?
I kind of have a template which I use my supervisors.
That's awesome. Can you tell us about it? What's in that template?
You read, try to get the aim first and then directly skip the introduction and go to the methodology.
Interesting. Skip the introduction, go to the methodology. Okay. Today I'm gonna tell you the opposite. And I'll explain why. Everybody sign the attendance register. So we get computer science, physics, bioscience, mathematics. Good. This lecture has different titles depending on what kind of mood I'm in. This title is on close and distant reading of research papers. I'll explain what those terms mean during the seminar. Has anybody ever heard of those terms before? Close and distant reading of research papers? Yeah, it's not very common terminology. So, just a little bit of the big picture. As part of a researcher's job is to try to present solutions to unsolved problems, right? That's our ultimate goal. Present new solutions to unsolved problems or better solutions to already solved problems. Right? But new solutions, no matter what. So in order to try to develop new solutions to either new problems or old problems, we want to find out what existing solutions are or have already been published. That's our goal. Right, during our literature review. We don't want to repeat history in this case and work on a solution to a problem only to discover somebody already published this solution. Right, that's what we're trying to avoid. So that means we're looking at previous research papers to find out what problems have been solved and what the solutions to those problems are, right? So we don't repeat solved problems. However, every research paper is very complicated and very dense, full of information. It's very dense. A single research paper is usually the result of 5 to 10 person years, right, packed into 10 pages. 5 to 10 person years, right? For every author, right, there might be 5 authors, and they all worked for 2 years on the research paper. That's 10 person years compacted into a research paper, right? So this is it's a difficult configuration, and you are being asked to process that information over maybe 100 or 200 research papers, right? It's very complicated, and it's very challenging. This is kind of part of the literature explosion, and there are thousands and millions of previously published scientific research papers, and it's very overwhelming, or it can be very overwhelming to sort of swim through that ocean of data that's related to your project. So that's what this seminar is about, a coping strategy, you could say, to help navigate the vast volume of previously published research papers. I can see everybody is on the edge of their seats. I can't wait to see what this is all about. So how can we navigate through this massive complexity? And this is the overview of what we're going to talk about. There is related work on this topic. I'll just mention it very briefly. But this is the only seminar of its kind in the whole world. I've never seen a seminar like this before anywhere, period. We're going to discuss the concepts of close and distant reading. And we're going to also discuss the idea of concept versus implementation. We're going to decouple these things from each other in your head. And then we're going to do some exercises, some examples, how to extract the essentials from a scientific research paper. So you have a scientific research paper. It has what's an overwhelming amount of information in it, but you don't need all of the information. There are some essential pieces that you do need, and that's what we're going to focus on. What are those essential elements that you need to extract? And then we're going to look at some examples. So not all of the information in a research paper is of equal importance. And we're looking at this through the lens of a PhD candidate, possibly a master's by research candidate, and that person is trying to identify solved and unsolved problems and constructing a literature survey. So that's typically stage 1 of your research, right? Conduct a literature survey on your topic to find out what the solved and unsolved problems are and what could be a good systematic strategy for doing that. So this is for writing a survey paper or a literature review. And the reason we look at literature reviews is, again, to determine the solved and unsolved problems in our respective areas. And this is based on writing lots of survey papers. So in computer science, we have published many survey papers ourselves. This is something we're always working on. Survey papers are great things to publish. I know it is unusual to publish a literature survey, and not all of you will actually publish a literature survey, but if you can manage to publish a literature survey, they're very highly cited papers. They're typically, a survey paper is more highly cited than a standard research paper. And also, I've supervised about 11 PhD students to completion now. So this is also based on my own personal experience supervising PhD candidates. Now, there is related literature on this topic. If you Google like writing literature surveys, you can find lots of different hits on writing literature surveys. Right? Some are more useful than others. The focus of this seminar is a single research paper. You have a single research paper in your hand, how to systematically extract what you need from that. And that's one little piece of your big survey. You can also find papers about how to read research papers from the perspective of a reviewer. That's probably not what you're interested in, but there are papers on that topic, and that you might find them useful to have a look at. And there are a number of papers that people like to publish on how to get rejected. Right? Those are all related topics, like how to get your paper rejected from publication. Now, the material in this seminar has been published, so you can actually Google a journal paper called How to Read a Visualization Research Paper. That's what this is based on. So this is also published material. Any questions so far? Everybody's excited to learn about how to do this. I can feel the excitement. Okay, close versus distant reading. When you read text by default, that's called close reading. So a close reading of text is picking up a piece of paper, starting with the first word, and then reading every single word in order from start to finish. That's called close reading. So that's what you do by default. That's what you're familiar with. But there's also something called distant reading, and that is when you replace the original texts with something visual that represents that thing you're reading. It could be a diagram, it could be a symbol, it could be a drawing, it could be a graph. In this example, this is an example of a graph. And every glyph or every shape in this graph is a research paper. And the research papers are in different hierarchies. So this is a research paper. And then all of these research papers were published after this one, and they all based on this one. So they used the results of this research paper to publish new ones. And then all of these are children of this predecessor. So all three of these authors published their findings based on this paper. And these papers have different properties, right? And the properties are mapped to different shapes and different colors. That's an example of a distant reading of a paper. You don't actually see the original text. You only see a little summary. It's a summary of the characteristics of the paper in the form of a symbol. And in this case, we can see the relationship between the different papers that were published. That's very distant, it's very abstract. Right? That's what we call a distant reading. What we're going to talk about today is something that kind of is halfway in between close and distant reading. We're going to do close reading, but we're not going to do a close reading of an entire research paper. We're going to look for special elements that we extract from that. And so conceptually, it's not completely a close reading, but it's not a complete distant reading either. It's like a halfway in between. And halfway in between, this is like an illustration of something that's halfway in between. This is a distant representation of a text, and then the user has clicked on a special subset of the text, and they get the close reading. So conceptually, what we're doing today is scanning through the research papers, picking out the pieces that we think are important, and then doing the close reading of those specific pieces, rather than just trying to read the whole thing, because it takes a long time. Any questions so far? It's all very abstract. It starts out very abstract, and then we get more and more detailed as we progress. The next aspect is this concept versus implementation. This is really important to decouple in your mind. You may never tried to separate these two ideas in your head until today, but it's really a very, very important element in reading previous scientific research papers. So a concept is a general notion or idea, right? It's in a person's mind. It's an idea. It could be written down on paper, right? An idea of something formed by mentally combining all its characteristics or particulars, a construct. A directly conceived or intuited object of thought. These are all concepts. Now, it's very important when you're reading a scientific research paper to decouple the concept of that paper from its implementation. And that's true about everything, actually, not just scientific research papers. So the implementation of an idea is to take that abstract concept or that abstract idea in somebody's head and bring it into reality, to make it a physical reality. That's called implementation. So it's going from abstract to concrete. Implementation, the act of accomplishing some aim or executing some order. Right? The act of implementing or providing a practical means for accomplishing something, carrying into effect. So concept is an abstract idea, and implementation is taking that idea and actually constructing it. And that's usually what happens with you guys, isn't it? Your supervisor says, I have this idea, and then it's your job to make it a reality, to implement the idea. Yeah. That's a very important distinction, those two things. So a concept, just to give an example, a concept is an idea or a thought. The implementation is the realization or the bringing of that thought into reality. And the concept is usually imagined, starts out in the imagination, whereas the implementation takes it from being imaginary into something real. And so a concept is implemented. Here's a very boring example. A writing utensil. That's a concept, you could say, or a writing instrument. Right? You could call it whatever you want. As a concept, I've written down a tool that can be used to communicate with others using symbols drawn by a person or an animal. A writing utensil or a writing tool. It's a thing that I can use to draw with a well-defined alphabet, presumably. A writing utensil. That's a concept. It's something I can imagine, right? And I don't actually need to have an implementation. I can just imagine it. Now, the implementation of a writing utensil takes on an infinite number of forms. A writing utensil, the implementation is the realization of that concept, and it has an infinite number of different forms. So it could be a pencil, it could be a colored pencil, it could be chalk, it could be a pen, it could be a marker, a dry marker, permanent marker, it could be paint, it could be my finger. Like, there are a million different kinds of pens and pencils. It could be crayons. So for every concept, there are a million or more, or essentially infinite number of implementations. That's really important. Does that make sense to everybody now? Like, do you think you have the difference between concept and implementation? You feel like you've got these things separated in your mind? Because they're not the same. Yeah? So for every concept, there are many different kinds of implementations. It's essentially unlimited. And this is a very important distinction when you're reading a research paper and writing one, but when you're reading one. Because when you're reading a research paper, you are trying, guess what you're trying to extract? The concept or the implementation? Anybody want to take a guess?
Results.
When you're at the stage where you're trying to determine solved and unsolved problems, you are trying to extract the concept behind that research paper.
I mean, this is a question. So we are both mathematicians that we were discussing. I think that in mathematics, concept and implementation are almost the same thing. In pure math, I mean. Because there are not many ways in which you can implement a concept, because the concept itself is already the implementation somehow.
Well, the concept, we'll talk more about what the difference between the concept and implementation is. But you might be writing a proof, right, for your mathematics.
Yeah.
But you can write more than one proof for a given concept,
Yeah.
right? Your contribution might be a more efficient proof for a given concept. At the conceptual level, you're trying to determine the solved and unsolved problems.
So in this case, the implementation will be the proof, not the theorem itself.
Exactly, yes. And I have an example from mathematics, I'm pretty sure, today as well. Any other comments or questions? In physics, you have a hypothesis. That's the concept. And then you might have an experiment that confirms or refutes that hypothesis. That's the implementation. That's the same with bioscience. And is there anybody else? Computer science. In computer science, you start out with a hypothesis, and then you confirm or refute that hypothesis with software, typically. So the software is the implementation. The hypothesis is the concept. So when you're trying to determine solved and unsolved problems, you're looking for concepts. You're looking at the conceptual level. You don't want to necessarily write a proof for a theorem that has already been proven, for example. So one of the essential elements of reading a research paper and extracting the essentials is the concept. What at the conceptual level are the authors trying to do? There are different ways to formulate this question, but it all is the same, right? It won't necessarily be called, here's the concept behind this paper. In the paper terminology itself, you'll see words like the goal. What is the goal that the authors are trying to reach? Right? That's the concept. Another is, what is the contribution of the paper? That's another reformulation of the same thing. Right? We conduct the first experiment that verifies the presence of blah, blah, blah. Right? So those are all the same. You're trying to extract the goal of the work and the contribution of the paper, because every research paper makes a scientific contribution to knowledge. What is that specific contribution to knowledge that the paper is making? That's the concept behind the paper. And that's one of the essential elements that you would extract for every single research paper. Another way of formulating is what's new. What have the authors done that's actually new? That's another way of saying the same thing. Right? That's the concept. Then the implementation is, now you've got it separated in your head. What are the authors trying to do versus how are they trying to do it? So one of them is the what, and one of them is the how. Now when you pick up a research paper, the complexity comes from the how. This is where all the troubles are. But when you're doing a literature search trying to identify the solved and unsolved problems, the how is not essential. That's not the essential thing that you need to know about. That's what you would say, you would give that how the distant, that corresponds to the distant reading. The concept is the close reading, and the how is the distant reading. So this is a stumbling block. This is a stumbling block for a lot of researchers. They get caught up in the details of how something is done, but it's not necessary. It's not necessary. Another essential piece of information to extract from a research paper is typically the one or two previous research papers that this current paper is really built upon. You pick up a scientific research paper, it might have 30 or 40 or 50 citations, but usually there are one or two citations that are the most important, maybe just one. And that is an essential element to pick up on. And then I have this section here called data characteristics. This is a section that would have to be adapted to your specific field, right? But the characteristics of the data that the researchers are studying is an essential property that you want to extract from your research papers. Like, is the data spatial? Is it associated with space, or is it abstract? Is it temporal? Does it include a temporal aspect, or is it static? What's the resolution of the data set? So how big is it, or how small is it? Like, a lot of us are studying data here. Is anybody here studying data as part of their research? Generating data, experimental data, or simulation data, something like that? And so on. These are all data characteristics. So if you're working with data, you want to summarize the data characteristics that are important for whatever it is that you're studying. So these are the essential elements, and now we're going to go into these essential elements in a little bit more detail. But there are 1, 2, 3, 4 absolutely essential characteristics that you extract from your scientific research papers. And now we can go back to a template. So now you can actually sit down with a template and look at every research paper in the same way, using the same lens in a systematic way to get to accelerate your literature search and make it structured, systematic, faster, and more logical, rather than this kind of chaotic, overwhelming, crazy jungle of just previously published research papers, which is typically what you can have now, like just a stack of research papers, and your mind is just like, what am I gonna do? So this is it. You extract the concept, you extract the implementation, it's also called the method, right? In computer science it's called implementation, but in other fields it will be called the method, like the experiment that's being conducted, or the simulation that's being conducted, and so on. The related work and data characteristics. I also have other optional ones: analysis techniques, application domain, and other information. Like, I think when you're summarizing a research paper, it's also nice to have the sample image from that paper in your summary. Has anybody here been given the assignment of summarizing a specific research paper? Has anybody ever had to do that before? No? Okay, that's interesting. Well, if you do have that task one day, which you will, you can use this template to do that. And your supervisor will be like, oh, gosh, wow, where did you learn that? So here's an example, an actual example. This is a research paper. It's called Fast and Resolution Independent Line Integral Convolution. Right? Very scary title, right? Doesn't mean anything. Yeah. This is a computer science example, by the way. I'm going to do an example from each discipline in science. So this is a paper, a well-known published paper, and this is my summary of that paper based on the strategy that I'm proposing. So it has a title, it has a concept. What is the concept? This paper presents a faster version of the line integral convolution algorithm. So it takes a previous algorithm, a previous process, and it produces a new one that's much faster. That's the concept. One sentence summary of the concept. Okay, 2 sentences. You're allowed 2 sentences. 3 if you want. Now here's the so I can extract the concept from just reading the abstract in the introduction. That's where the concept comes from. You read the abstract in the introduction. The implementation, this is all on page 1. The implementation is the rest of the pages almost. Page 1 is the intro, page 2 is related work. Pages 3 through 15 or whatever, they're all about the implementation. But the implementation is not important, actually. You don't want to sit around and study the implementation for days and days and days, because it's not important. So instead of sitting around studying the implementation for days and days and days, I write 1 or 2 sentence summary of the implementation, right? Which is just, they reduce the number of redundant streamline computations. They also use an improved streamline integrated with adaptive step size control. So it's just a 2-sentence summary of the implementation. It doesn't go into all the details. It's just it's a distant view of the implementation, you could say. And then I identified there's one previous paper that this is built on. There's a related work section with maybe 30 different papers in it, but there's one paper that is the most important, and I've identified that and put it in the related work section. And then I've written down the data characteristics, like it's 2-dimensional data, it's static, the grid resolution is uniform, it's given on a Cartesian grid, and this is vector field data. And here's a picture, an image of that paper. So that's a computer science example. This is a demonstration of extracting the essentials from a research paper. Now, if you're a new student or something like that, you might pick up a research paper and you might read it from start to finish, and it takes hours. And you might try to write a summary like this, and it might take a few hours. But the more you practice this, and the better at it you get, the faster this is. So I can pick up a computer science research paper, and I can write the summary like this in 10 minutes. I only need 10 minutes to pick it up, get the information, because I've had a lot. Huh?
With reading.
Yes, that's right, that's right. Because I've had so much practice. I know how to extract the concept. I know how to summarize the implementation in just a few sentences. And the most difficult, time-consuming part is the related work. To try to figure out, okay, is there a research paper here that they've built on, that they've really focused in on? And then the data characteristics are very easy to find, because then you can skip to the results section. I think you were mentioning like skipping to the results section and extracting those. Does anybody believe me?
I somehow don't believe in 10 minutes. Sorry.
I know, I totally understand. It does seem unbelievable.
Because some papers have sections and there are some important conclusions in the middle.
Yep.
So can you find all of them in 10 minutes?
Yes, so you can extract the concept from the abstract and the introduction, always. It doesn't matter which research paper you're looking at.
Okay. So you need to read
Most...
But, for example, can you get implementation? I mean, I guess, at least in mathematics, you probably can get implementation from the abstract as well. But just a few sentences. So it's okay.
That's right.
You don't need to read everything, but maybe you can lose some, I don't know, some core passage by just reading the abstract and not the actual text. I don't know.
So the implementation, what you're losing here are the implementation details. You're leaving those out. In your case, you know a proof was written, right? Maybe there's a special strategy for writing proofs, like the authors used induction to complete their proof, or I don't know what the different types of proofs are. But that would be your one-sentence summary of the implementation. They use this style of proof to prove their hypothesis. And that would be it. That would be the whole, you'd write a comment about what style of the proof is. Maybe how long the proof is, if it's like 20 pages or something. Or just a few comments about the proof. But you wouldn't be going through the proof line by line by line and going, oh my gosh, how did they get from this line to this line? That's not what you want. It's not what you want at this point. Because you're trying to identify the solved and unsolved problems. That's the idea at this point. I'm going to go over some more examples. I can feel the anticipation. So I was curious too. I understand your skepticism, because I learned this as a computer scientist. I'm a computer scientist. And I thought, is this going to apply so easily to geography and bioscience and chemistry and physics and mathematics? Like, is it really going to be so easy to just take this and... But the answer is definite yes. Like, you could just take the same thing and apply it to anything, any research paper. It doesn't even have to be science. By the way, those are the core, but you can include other things. If you decide that there's some other aspect of the research paper that's very important for your literature survey, you can also include that. And your supervisor might say, oh, but when you're reading the research papers, can you write down this part too? Like how many authors there are or something, or how many figures there are, or just some other aspects, right? Here I've got analysis techniques, like what basic techniques are used. Statistics used, In your case, it would be proof theory, visualization. Are there any special software tools used? And what application domain are the visualization techniques being applied to, or whatever? Like which? Some research papers are cross-disciplinary, and they might apply to different, multiple areas. Okay, here's another example. This one is again computer science, but I have other non-computer science examples. This is another scientific research paper. The title, Marching Cubes, a high-resolution 3D surface construction algorithm. So it's an algorithm, some software that constructs surfaces that look like these. Yeah. That's the idea. So the concept, this paper describes a novel algorithm for construction of large isosurfaces. So that's a special class of surfaces. It doesn't matter for you guys what isosurfaces are. Anybody happen to know what an isosurface is? It's not important. It's an algorithm that extracts these special kinds of surfaces. That's the concept. One sentence. Now the implementation is broken down into 6 stages. So I've just written those 6 stages down. I've not gone, most of the paper is about the implementation. And it's true about all papers. I've written down the 1-sentence summary of the implementation. There's 1 paper or 2 papers that this work extends that are very important. Right? The rest are related, but they're not that important. And then I've written down the data characteristics, the analysis techniques, and the application domain. This happens to be extremely useful for medical data. Right? So CT scan data and magnetic resonance imaging data. Here, we got some physics people here? Here's an example from physics. Now, when I was looking for papers to summarize from other domains other than computer science, I Googled like the most famous physics paper, for example, the world's most cited physics paper. And that's this one. Did you guys know that? This is the world's most highly cited physics paper. Well, you learned something new. It's the dictionary of subatomic particles. It's like the master reference of subatomic particles. There's a lot of subatomic particle research going on in physics. I know that. So here's the same template being applied to a completely different kind of paper. This is a literature review paper of particle physics. It is a reference for all known measured particles for the hypothetical particles. So is that 1 sentence? 2 sentences. The concept of the paper, the most highly cited paper in physics. The implementation. The review collects data from previous editions and adds 2,658 new measurements from 644 published research papers and adds it to the database, so to speak. And then I've included a second sentence here about some of the new subatomic particles that have been added to the reference list. And then I've got the related work, right, here. And the related work is just the previously published version of the same survey paper. So they publish this survey paper every 5 or 10 years, the same survey paper, so they bring it up to date. I've written down data characteristics, over 30,000 measurements. The analysis techniques is just a special kind of literature search. This is a survey paper. And the application domain, I have a reference material for particle physics. And I just, for the fun of it, when I find a research paper with a special URL, I like to make a note of it. So this one had a special URL with all the tables, reviews, and everything. Unfortunately, there was not a single interesting image in the whole thing, which is really sad. Which is why I don't study physics. So that's an example of the same template being applied to the most famous physics paper ever published. Questions so far?
Yeah. So this example seems quite easy, but how do you find the related work? Because some papers have like 40 references.
Yes.
And they may not. I guess one method may be the one that's referenced the most, but then that's not always the case. How do you find it so easy to find the most relevant work in the paper?
Let me go to this one. I'll summarize this one and your question at the same time. So a really good research paper has a related work section. And you can, this is what you're asking, in my opinion, is the most challenging part. Finding that one or two previously published research papers that are the most important. For papers with a well-written related work section, it's pretty straightforward. You just have to read it, and the authors will usually say, like, our work is built upon this previously published literature. Now for this, when I did this paper summary, anybody recognize this paper? Who's bioscience here? Anybody bioscience? This is the most cited paper in bioscience. Like I don't know if it's the #1, but it's like in the top 3. I thought, okay, I have to choose somehow. I have like 50 million bioscience papers to choose from. How am I going to choose one? So I Googled like the most highly cited bioscience papers, and this is one of them. So, and believe me, I'm not a bioscientist by any stretch of the imagination. So this was a really interesting experiment for me. Like, I thought, like, is this going to work? Exactly what you thought. So the concept, procedures are described for the detection and measurement of protein using the phenol reagent. Sometimes even small amounts of protein are discovered. So that's it. That is the concept. To try to discover protein, to search for protein. And it's a very simple concept, actually, at the conceptual level. The method and the implementation and the experiments are not that simple. Like, I can't understand all the experiments. I don't know all the details, and I can't follow those procedures and things like that. But I can still write a 1 or 2 sentence summary of the experiment that they describe and they perform in there. So the conditions under which full and phenol can be used to detect protein are varied with respect to pH, so that's one of the dependent variables, reaction time, concentration of reactants, and substances that may interfere with detection. So they have their experimental setup and they vary these different parameters, like pH level, reaction time, and so on, until they discover protein and find out which configurations extract protein. So that's my 1 sentence summary of the implementation. Now this one is a pain. This paper is a pain because it has no related work section. So I had to do a kind of fast reading, like you said, of all the citations, picking out all the citations to find out which one was the most important. So that was like the most manually intensive part, because there was no related work section. But in the end, I did find out that there are 2 previous research papers that are really the core basis for this one. And for data characteristics, I listed the substances that they use to detect protein, the reagents they use to detect the proteins. Here, for analysis techniques, I just cut out the sample figure. There's a sample figure, very low resolution. And this is biochemical, the application we're doing.
By related work, you mean that there's a section related work or just looking at the references?
This one has no related work section, unfortunately.
But because usually, I don't know, in mathematics there's no related work, there's just references in the end.
Really? You don't have a special related work section?
No.
Quite similar to physics as well. It's not really.
There's not really?
Sometimes in the abstract, you can understand which are the main references by the abstract, but there's no
related work section. That makes it more difficult. That
So
makes
about
it-
10 minutes.
Maybe it costs an extra 5 minutes if there's no related work section. Yeah. So that part will slow you down, that part. Yeah.
No, I don't. Going to
Here's an example from mathematics, by the way. This is, again, a top-cited mathematics paper. It may be the most cited mathematics paper of all time. It's in the top. But it's not really theory. It's not really on the theory side. It's more on the applied mathematics side. It's got a funny title. New features of form. Like, that's the whole title. It's kind of a very concise and boring title. But it's very highly cited, like maybe not millions of citations, but. So this, I was like, oh no, am I going to be able to do this with mathematics? This one's super easy. This one is like, this was a 10-minute job.
Yes, but it's not.
It's not a theory.
The mathematics.
That's what you wanted to say.
I mean, it looks more like computer science, no?
It is a little bit
It's
more
a
like
library,
computer
it's some
science.
software.
It's like, yeah, it's a software library. But it's got the highest impact of all the mathematics papers. So
Yeah, but
it's
then you have to
important.
play number impacts.
If you publish a paper that gets half this many citations, you'll win a Nobel Prize in mathematics. The next version of a software library called Form is presented. It performs calculations in quantum field theory. This paper describes the new features added for version 3.0 to match the latest developments in quantum field theory. So very, very easy concept. And then I wrote a few things about the implementation, right? 1, 2, 3, 4 sentences. And this one was very easy. It was pretty clear from reading what the most previously related work is. The authors state very explicitly it's a successor to another library. So it was easy to find out which one. And then I wrote down about the other one. So the data characteristics, this was the most difficult part of this summary, was to try to figure out what is the data that they're processing. This was the part that slowed me down. Maybe it caused me to go over 10 minutes. Because I was like, where's the data? I couldn't find the data. All I could see was that it implicitly processes scalar and vector field data, but it never stated explicitly what kind of data it processes. Analysis techniques is not important here. Quantum field theory is important. And look, there's a special URL for the software, so I wrote that down for anybody that wants more information. Bioscience, geography, and there's nobody from geography here, but we'll go through the exercise anyways. because it really works. Like, if you apply this strategy, you will be so much more successful with your literature review. And you'll be able to really cruise through the papers and not waste days and days studying the implementation details or the proof details of just one paper. Now, after your literature review is finished, there might be a paper that turns out to be very important for you. You know, you may have done your search. The idea is to do your search, find everything that's important, and then maybe you've discovered one paper that's so important, you need to do a close reading of the paper. That could happen, but that's after the literature review. After your supervisor says, look, this thing is super important, you've got to read this thing from start to finish, like close. He's not going to use the close reading terminology. So an example from geography, this is a top-sided geography paper. It's completely different than the other paper summaries. It's completely different. Secure the Volume, Vertical Geopolitics and the Depth of Power by Eldon. So the concept is political geography is usually divided by 2D surface areas. The hypothesis is that territory needs to include the third spatial dimension, or volume, or depth. That's the hypothesis. So that's the concept, very easy to extract the concept. The implementation is very different for this particular paper. The author presents a series of case studies, a set of examples, like here's an example of where it's important, here's another example of where this is important, and so on. And he bases his argument on those, what I would call case studies, a series of case studies. Again, this one was kind of a pain because there was no related work section. Most of the related work was in the introduction. And I found a paper, or two papers, where the term volume was first used when describing territory. And I labeled those as the most important. I wrote down data characteristics. The analysis techniques is just by example. This is political geography, and this is one of the examples that he discusses in the research paper. Any questions about that? And by the way, this is a screenshot of a work in progress literature survey. So this is what we do in computer science, although the resolution is really bad here. But this is the template right here. This is the template being used. You can see like title, concept, related work, and so on. And then we're putting these all together as an intermediate step before we publish our survey, the full-length survey. So each one of these represents a paper, right? Title, and so on. And those are sample images. Okay, and just one thing to wrap up. I'm repeating myself a little bit here, but we're talking today about the breadth part of your literature review. It's like the beginning, you're getting these stacks and stacks of research papers to build up a picture of the landscape in your respective fields. So you're trying to put together this conceptual map of solved and unsolved problems in your field. And that's the challenge we're addressing today. That's called breadth. You're in the breadth phase of your research. That's what that's called. After the breadth phase comes the depth phase. That's when the depth phase is when you've chosen a specific problem to solve and to work on, and you go deep in that direction. And that could be a time when someone else before you has also gone deep in that direction, and you need to actually pick up 1 or 2 research papers and read the details during the depth phase. And by the way, another reason people don't spend forever studying the implementation details of a research paper is because sometimes they're not all published. There could be important aspects of an implementation that you can't see because page limits have forced the authors to leave out that information. Right? So that can actually prevent you from understanding what's going on. And by the way, if you ever do have questions about a specific research paper, you can contact the authors and ask them questions. You don't have to just throw up your hands and say, I can't do this, or I don't know. Like, if there's some aspect of a research paper that doesn't make any sense to you, you can email the authors or give them a phone call and ask them. They'll be happy to hear from you. I used to do that when I was a PhD candidate. I still do it, actually. But I first started to do that when I was a PhD candidate. I wrote to the authors. And guess what? They wrote back. And another note, a good research direction is very difficult to judge based on a single research paper. You cannot just pick up one research paper and decide, this is a good direction to go in. I want to work on this problem. One research paper is not enough. You need a picture, a global picture, or a bigger picture of what's going on. Okay. Any questions or comments about that?
How does the template you've used form into, if you have to do a survey, how do you take the template that you've got and then get all the templates from all the places you've read, put it into a survey? And that's quite a large question. Can you summarise the process?
That is the subject of the next seminar. How to conduct a literature survey. But if you're I know you're dying to know the answer. The answer is already on the YouTube channel where this seminar series is hosted. So we record the seminars and we put them on the YouTube channel. And last year's seminar exactly answering your questions there already. So I'll warn you though, that's like, it's a lot of information to absorb in that seminar. I almost feel bad giving it because I feel like, oh my gosh, like, there's a lot to absorb there. And I don't know if it can all be taken in one sitting even. But luckily you don't have to take it all in one sitting. Any other questions? Good. I hope you all enjoyed it then. I'll see you next time.
Presentations attached as well.
Yes. So Google my name. That's one way to do it. Click on teaching and then College of Science Doctoral Training Seminar. That'll take you to it. I think you can put my name here as well. So Yep, there it is. Yeah.